Hello everyone, welcome back to the video lecture series on deep learning. In this video we are going to discuss about back propagation. What is back propagation? It's a training algorithm used for training feed-forward neural networks. It plays a very vital role in improving the predictions made by the neural networks. This is because the back propagation is able to improve the output of the neural network iteratively. So feed-forward neural network will have input layer to output layer, whereas back propagation is from going from the output layer to the input layer. So how we use the back propagation in feed forward neural network? So in feed forward neural network, you can see in the screen there is input layer, hidden layer, output layer. We go from the input layer. So the input layer is fed with the inputs x1, x2, x3 or the nodes or the neurons. Then there is a hidden layer which is connected with the input layer, and output layer will make some predictions or the classification. And we should know whether the output is correct or is there any error. For that, a strategy called as back propagation is applied, where we go back from output layer to the hidden layer, in turn to the input layer, and we analyze what is the difference between the expected outcome and the output. So we will analyze basically what is the error in the output. So back propagation means going back from output layer to the input layer. How does back propagation work? So we saw that back propagation is applied to the feed forward network. Feed forward neural network consists of one input layer, one or more hidden layers, and one output layer. Weights of inputs is proportional to the significance of the input. We can see in this diagram there is input layer, hidden layer, output layer, right? And there are two outputs. One is the predicted output and the actual output, right? Predicted output means what is the outcome and expected outcome, and what is the actual output. So we take the difference. So if the difference is high, then there is more error, right? That is what is basically an error. If there is a difference between the expected outcome and the actual output, there is an error. So we give this error data from the output layer to the input layer, and some corrections are of the weights or the adjustment of the weights are done, so that the difference between the predicted output and the actual output is almost zero, so that the errors can be minimized. Right, now we will see about the cost function. Cost function, it is abbreviated as J, indicates how accurately the model performs. It tells how far off our predicted output values are from the actual values. It's also of course known as the error, because the cost function quantifies the error. We aim to minimize the cost function. If cost function is less, then less error. Cost function is more, then more error. You can see in this graph is a three-dimensional graph. It has loss function in y-axis, and then it has weights in x and z axis. So we get a bell curve. So bottom of the bell curve represents less cost function. If this bell curve is other way around, right, and the peak of the bell curve is more cost function, so we need to have bell curve like this to have the less or minimal cost function. So this is the cost function or the error. So in the next video we will see more about the back propagation. Thank you.